Hi everyone, it's Miss Longarage here, and I'm going to make a video today that's different from the ones I normally make. I'm going to make a video about COVID-19 and how it relates to math. And I'm going to talk about COVID-19 and the logarithmic scale. The reason I'm making this video today is because one of my best friends, my friend who I've known for at least 30 years, is a nurse, and she lives in Toronto, and she's busy on the front line helping people. And she asked me to explain a little bit about the logarithmic scale to her, so I thought I'd share this video with her and with you. Now, in order to understand the logarithmic scale, you have to think back to grade 11 when you were learning about science, about petri dishes, about bacteria growing in petri dishes. And when you were in grade 11, you would have heard about bacteria doubling in time in a petri dish. And anything that doubles is considered an exponential function. And so an exponential function is a graph that starts increasing slowly and then increases very quickly. And so when you put an exponential function on a logarithmic scale, the graph actually looks linear. You might ask, what is a logarithmic scale? Well, typically when we draw our y-axis, we jump evenly. We jump 10, 20, 30, 40, 50, 60, 70, 80, for example, or 100, 200, 300, 400. That's what we're used to. When we draw a logarithmic scale, what we do is we think about exponents, because logarithms and exponents, they're inverses of each other. So if we're drawing a logarithmic scale, what we do is instead of graphing 1, 2, 3, 4, 5, 6, 7 on the vertical axis, we graph 10 to the exponent 1, which is 10, and then 10 to the exponent 2, which is 100, and 10 to the exponent 3, which is 1,000, 10 to the exponent 4, which is 10,000, 10 to the exponent 5, which is 100,000, and so on. So that's what a logarithmic scale is. It's just jumping by 10 to the exponent 0, 1, 2, 3, 4, 5, 6, 7. And a logarithmic scale doesn't need to jump by tens, by base 10, but that's just what we are used to. So typically when you see logarithmic scales, they have base 10. So let's go back to my initial example about the petri dish and the bacteria that's growing in the petri dish. If at the beginning, on day 0, there was one bacteria and it kept doubling over and over, that means on the next day there would be 2, and then 4, and then 8, and then 16, and then 32, and so on and so on. So if I made a graph of that, and I did using Google Sheets, the graph would look like this. Now, what's really interesting is when I change the scale, instead of making it jump evenly, if I make it jump using a logarithmic scale, my graph, instead of looking like a sharp turn up, looks like a straight line. Let's go back to my table of values where I was doubling each time. And I'm going to take that table of values, I'm going to have it start off doubling like you would expect a bacteria to double. But then over time, I'm going to have its growth rate reduce, so it's less than doubling later on in the table. So if you look at the table I've drawn, it starts by doubling 1, 2, 4, 8, 16. But then you can see that after that, it is not doubling anymore. And when you make the graph for it using the logarithmic scale, it looks like the graph is relatively straight. And so it appears that, yes, it must be still growing exponentially. But if I were to draw a straight line on top of the graph, I can see that actually at the end of the graph, this line, which I thought was relatively straight, is actually curving off beneath the linear line, which would suggest that it's no longer growing exponentially at the end. And that's what they're talking about when they talk about leveling off the curve. They want it, when it's placed on a logarithmic scale, to level off, so fall beneath that straight line. And when it's doing that, it means the bacteria, whatever is growing, is no longer growing exponentially, it's growing at a slower rate. So what I've done is I've gone online, I've searched up the data, and I found the world's cases of coronavirus infection starting in January until now in May. And you'll see that data, it's the dark blue curve. And so what I want to show you is that the dark blue curve is what's happening, and the light blue curve is actually an exponential function. So what we can see is now our dark blue curve is underneath the light blue curve, which suggests that our growth rate is declining. It's not the same level of exponential that it was before. And that's what we are talking about when we're talking about leveling the curve. Now, let's look at that on a logarithmic scale. So I've taken the same curve that was on a linear scale and put it on a logarithmic scale. And we can see that our curve now seems to be falling away from something that's linear. Now remember, if the bacteria was growing exponentially, the graph should be linear when it's on a logarithmic scale. Now, just to show what I'm saying, the light blue line would be something linear. Our blue curve seems to be falling beneath that. And if you look at this graph here where I've extrapolated, it looks like our dark blue curve is going to definitely go lower than the linear curve as time goes on, which would suggest that the coronavirus is no longer growing exponentially. And that's what they're referring to when they are talking about leveling off the curve. So remember that when we use a logarithmic scale, the reason we use it is to see whether our curve is beneath the linear line. Because as long as it's beneath the linear line, then that means that our bacteria is no longer growing at the same exponential rate it was before. It's actually, the rate is decreasing, which would suggest that things are getting better. I hope that video helped a bit. I know it's super confusing, but just remember that we want that dark blue curve that we see on the screen now to trend beneath the light blue curve. And as long as that is happening, that means that things are getting better. Thanks, Debbie, for asking this question. It gave me the chance to research a bit and to learn more about the logarithmic scale, and I hope that this video was useful. Bye, everyone, and tomorrow I'll resume teaching algebra and solving systems.